Okay. So just like before, we know we can't get a denominator of 0. So that means sine of x can't equal 0. Which once again means that x can't equal 0, positive or negative pi, positive or negative 2 pi, positive or negative 3 pi, and so forth and so on and so on. Till the end of whenever. Okay. Now let's say if we have our graph. And make sure I got enough room. Okay, so let's say this is our pi over 2, our pi, our 3 pi over 2, and our 2 pi. And give a quick sketch of our sine wave, which looks a little bit like that. Okay, so we know, and go over to negative pi over 2. We'll go to negative pi. So negative pi over 2 and negative pi. Okay, so we know they can never equal 0, which means all the points where sine is equal to 0, once again, becomes asymptotes, which means 0 is 1 also, but we can't put 1 there. Okay, so if you remember, just kind of a quick, we can erase these completely because we're going to focus more on tangent than anything. So these, you can actually erase them if you want, or you can draw a new one starting out. Okay. Now if you remember tangent, tangent goes between negative pi over 2 and pi over 2, like that, because remember, this is your tangent. Uh-oh. Okay, so remember, this is your tangent, that's one of your tangent, it keeps on going like that. Okay, so now, since it's the reciprocal, this is flipped, and this is flipped. So really, you're just getting your tangents and you're flipping them. Okay, so really, instead of getting the entire thing, you can just have it flip. Uh-oh, move that over just a bit more. And actually, that one can flip up. There. And that one flips there. Okay, so actually what it looks like, I'll redraw it because right now it looks a little bit odd. Oh, where'd it go, where'd it go? Oh, make sure I didn't. Oh, actually I went too far over. That actually should just go down to not past pi over 2. Went too far. So same thing with this one, shouldn't pass pi over 2. And same thing here, should not pass 3 pi over 2. All right, and it would just repeat, that one shouldn't pass negative pi over 2. Okay, so it's kind of looking like that. I'll redraw it because it looks a little bit messy now. Okay, so what we have here is we have values where we know that you have, where is it? From 0 to pi over 2, we know what the values are, and we know what the values are from here to here. So if we redraw it, we have our x, we have our y, and we have our 0 to, remember, our pi, and 2 pi, those are our vertical asymptotes. And we have our negative pi, and we keep on going. We have our vertical asymptotes there. What we have is you have, and remember this is an asymptote too, you have the graph that's pretty much tangent, but it's flipped, but you have different asymptotes. So instead of tangent going like that, cotangent goes like that. Okay. Where with sine, it went from, not sine, but with tangent, it went from negative pi over 2 to positive pi over 2. With cotangent, it goes from 0 to pi, pi to 2 pi, 2 pi to 3 pi. It kind of shifted. Because remember, since it's now shifting and it's flipped from tangent, it's just the other way around. So this is your graph for cotangent of x. So any questions on that one? All right. Oh, leave it up in case anyone's still writing. All right. Oh. Okay, so now what we're going to do is we're going to kind of go back to your even and odd functions. Okay, so if you remember your even functions, that's where if you replace x with negative x, and if you get the exact same function, then you know it's even. So that's where f of negative x is equal to your f of x. You know, if you have an odd function, that's when if you replace x with negative x and you equal the negative of the function you started out with, that's how you know it's odd. So f of negative x equals negative of f of x. Okay. So basically they just mean an even function is symmetric across the y-axis, which basically looks like a mirror image of each other. And the odd function is symmetric across the origin, which looks like if you flipped it across the y-axis, then again over the x-axis. So this is symmetric across the y-axis. And odd functions are symmetric across the origin. Okay, so if we go back to our graphs, just to take a quick look. Well, actually, I'll just redraw it. Your sine of x, remember that looks like that, and it actually brings back up again here. So if you just kind of stop from here to here, it looks like if you flip it over the y-axis and then flip it again over the x-axis, it will be symmetric. So sine is actually an odd function. Okay, because if you have sine of pi over 2, that's equal to 1. And sine of negative pi over 2 would be negative 1. Okay. So if we go for cosine, same thing. Well, it's not odd, but same thing as far as application. So cosine, if we do a quick sketch for cosine, remember it starts at 1. And it keeps on going on the other side. Okay. So if you look at your y-axis, it looks like a mirror image of each other. So you know that cosine is an even function. Okay, so if we look at tangent, and we'll do a quick graph of tangent. And we have our asymptotes, and tangent looks like that. If you notice with tangent, if you get the right side of the y-axis, if you flip it and then flip it again, it falls right into place. So you know that this is an odd function. Okay, so the only even function you have out of those three would be cosine. Okay. So here, if cosine is even, then that means if you flipped it, it would be even too. Because if you flip this, it would be the exact same thing, just flipped. It would still be symmetric with respect to the y-axis. So if cosine of e is even, then secant of x is even. Okay. So really, those are the only two even functions. Because remember, your secant, you're just flipping it. So again, if you look on the other side of the y-axis, you have half here and half there. You have this flipped and that flipped, so it's even looks the same on both sides. Now, as far as the odd one goes, everything else is odd. Okay? Because if you just flip them all over, you still have the same odd-looking functions. So if sine of x and tangent of x are odd, then cosecant and cotangent are odd. Okay, so that's usually the easiest way to remember that is cosine and its reciprocals are the only odd ones. I mean, the only even ones. Everything else is odd. Which actually would come in handy because you have some questions that ask whether or not what's the value of negative sine functions, or cosine or cosecant. And knowing this kind of helps out. All right, anyone's still writing? Okay. So let's say, for example, if we wanted to find the value of, let's say for question A, cosine of negative pi over 4, and for question B, sine of negative pi over 2. Now you don't have to graph it or draw any charts or anything like that. For these, we know that, let's say for A, cosine of x is even. So we know when a function is even, that just means that f of negative x equals f of x. Okay? So for cosine, that means that cosine of negative x is just equal to cosine of x. Okay? So if we have cosine of negative pi over 4, that's just equal to cosine of pi over 4. Which is square root of 2 over 2. And that would be your answer. Because remember, no matter what's in here, whether it's positive or negative, it's equal if it's even. So here, a negative pi over 4 and positive cosine of pi over 4 are the exact same. All right. Any questions on that one? All right, so let's say, for example, I can do another example, got to do B. We have sine of negative pi over 2. Okay. So we know that sine is an odd function. Okay. So we know whenever it's odd, that means that f of negative x, that negative just goes out to the front. It goes negative f of x. So if we're applying that to sine of x, sine of negative x, that negative just goes out to the front. Equals negative sine of x. Okay? So remember, with an even function, the negative just kind of disappears. With an odd function, that negative just goes out to the front. Okay, so that means that sine of negative pi over 2 is equal to negative sine of pi over 2. Okay, so we know that sine of pi over 2 is equal to negative 1. Nope, it's equal to 1. Sorry about that. So we know that sine of positive pi over 2 is equal to 1. So this is just negative times 1, which is negative 1. All right, so any questions on that one? All right, oh, this one had another example in here. Yeah, here we go. Thought I had one. Out of order. All right, so let's say if we have, for example, if we're given that tangent of x is equal to 0.47, what is tangent of negative x? Remember, cosine and secant are the only even functions. So that means everything else is odd. So we know that tangent of x is an odd function. Okay? So that means that f of negative x equals, when it's odd, that negative just comes right out to the front. Negative f of x. So for tangent, means tangent of negative x, that negative just comes out to the front as negative tangent of x. Okay? So that means if you have tangent of x equals 0.47, tangent of negative x, which we know just comes right out to the front, is negative tangent of x, and we know that tangent of x is 0.47. So that's equal to negative 0.47. Actually, let me rewrite it underneath it. So which is negative, so we know tangent of negative x is negative 0.47. All right, so any questions on that one? All right, so let's do one more. Let's say if you're given cosecant of x is equal to negative 1/3, what is cosecant of negative x? Okay, and I'll leave that one for you to start on. Remember, cosine and secant are your only even ones. Everything else is odd, which means that negative goes out to the front. Right, so for this one, we know that cosecant of x is an odd function. Which means that, I'll write it underneath and run out of room, cosecant of negative x, since it's odd, that negative just goes out to the front, equals negative cosecant of x. Okay, so we know that cosecant of x is negative 1/3. Okay, that's given to us. So if we have cosecant of negative x, we know that negative goes out to the front. That's negative cosecant of x, which just ends up being negative cosecant of x, we can replace that with negative 1/3. So it ends up being positive 1/3. All right. So any questions on that one? All right. So let's see if we have the example of, say if we want to, let's say if, or better yet, given. Make sure you clean that up a little bit more. Let's say given secant of x equals, let's say 2.8. What is secant of negative x? And we'll do one more, and I'll let you start on these two. Let's say if you're given, which one didn't I do yet? We did tangent, we did secant, we did, and let's go with cotangent. Cotangent of x is equal to, no, actually it can't be 2.8. Make that 0.8. 0.8. And we'll make this, let's say 0.1. So if cotangent of x is 0.1, what is cotangent of negative x? All right, I'll let you start on those two. What are the only two even ones? Secant and cosine. Yep, that's it. Which means those are the only two ones where the negative sign just disappears. Oops. All right, so for these, we know that secant of x is an even function. Okay? So since it's even, we know that secant of x equals secant, well, secant of negative x equals secant of x. I'll keep it in order. So we know that secant of x, negative x, did it again, equals secant of x. There we go. There we go. So that means if secant of x is equal